Yesterday, we discussed the sum and difference identities. Today, we're going to talk about the double angle identities. And when we discuss the double angle identities, what we're talking about is having the same angle two times. So how we're going to see the double angle identities written is in this form. And in this case, we're going to start with sine, but we would see sine of 2 times x, meaning we're going to have the angle x and it will be doubled. Okay, so that's exactly why it's called the double angle identity. Now, what we're going to do with the next 3 slides is we are going to derive the double angle identities. And how we're going to derive the double angle identities is that we're going to use the sum identity. If I'm taking 2 times the same angle, that's no different than me saying that I have the same angle added together twice, right? 2 times x is the same as x plus x. So I am going to use what I know, which is the sine sum identity, and that is going to help me derive a formula for the double angle identity for sine. So let's recall the sine angle identity. Remember I said sine switches. So I know that sine of x plus x is going to be equal to the sine of x times the cosine of x plus the cosine of x times the sine of x. Now, if I look at this expansion, I notice I can go ahead and I can rewrite or interchange this expression at the end, cosine of x times sine of x, because we got multiplication here. So what I'm going to do is rewrite the expression like this. I can say this equals to the sine of x, cosine of x, plus sine of x, cosine of x. And if I rewrite it this way, I can look and I realize that I have the same thing twice that I'm adding together, which means, of course, I can simplify this by just saying that this is 2 times sine of x cosine of x. So I know that if I take x plus x, or the same angle twice, it's just going to be 2 times sine of x cosine of x. And what I've just did is I derived a formula for double angles. So the double angle formula for sine, or sine of 2x, is equal to 2 times sine of x cosine of x. All right, let's move on and let's derive a formula for cosine.